Welcome to an instructional video about when inequalities are involved in word problems. Previously, you have solved word problems and you have solved inequalities, variables. It's time for those two worlds to come together. You are already familiar with how to solve most of these word problems with equations, so this video will focus on solving them with inequalities. Let's start easy. We are going to translate these small sentences into algebra using inequality symbols. In a moment, after I've given you instructions, you will pause the video. You should write down each sentence and highlight or circle the words that tell you an inequality is involved. Then attempt to write the inequality using an inequality symbol and a variable. All right, go ahead and pause the video and try that out. Welcome back. Let's talk about each one of these sentences. Some of them are a little tricky, so if you got it wrong, that's okay. Just make a note of what confused you, and you have something to work on now. Number 1 says Karen is at least 40 years old. The words that tell us there is an inequality involved are these words, at least. Those are words comparing Karen and her age to the number 40. Let's talk about if we were to change this to an inequality using the variables and symbols. Let's use the variable k for Karen's age. And we're going to compare that again to 40. If you think about it, Karen is, again, at least 40 years old. I like to think about all the numbers that would make that statement true. If Karen was 41, if she was 42, even if she was 40, that would still be a true statement. Anything lower than that would not make the statement true. So Karen, being at least 40 years old, represented in an inequality, would be k, Karen's age, is greater than or equal to 40. In the next sentence, it says, at most 5 students have dropped the class. The words at most, just like at least, tell us there's an inequality involved. Let's make an inequality statement with symbols. Let's use S for the number of students that have dropped the course. And we're going to compare that to the number 5. At most 5 students have dropped the course. So, again, look at the numbers that would make that true. If 4 students have dropped the course, if 0 students have dropped the course, if 5 students have dropped the course, that would work. But anything bigger than 5 wouldn't work. So I'm going to say S is less than or equal to 5 because at most 5 students have dropped the course. Let's look at the next one. To qualify, your earnings cannot exceed $12,000. The words cannot exceed mean that there is a top boundary on the amount of earnings. So if we compare earnings, let's say E for earnings to the number 12,000, the earnings cannot be bigger than 12,000. They have to be less than or equal to 12,000. While we're here, let's talk about this. We could also write it another way. We could say that the earnings are 12,000 greater than or equal to the earnings. 12,000 is again still our top boundary. Because we flipped the entire inequality, it is still true. 12,000 is always going to be larger than or equal to my amount of earnings. Any of these ones we've already written could be written that way as well. Let's talk about the bobsled. The speed of the bobsled must exceed 40 kilometers per hour. The words must exceed tell us that the bobsled has an inequality with the number 40. So let's use B for bobsled team. Bobsled speed. Say that 5 times fast. The speed of the bobsled must exceed, so it must be greater than 40. It cannot be equal to 40, that wouldn't be enough, so it must be greater than 40. And we could, again, write it the other way. Let's look at the box that weighs less than a baby whale. This is an interesting one because there are two variables and no numbers. What we're comparing is a box to a baby whale. I imagine this box weighs less than baby whale. Must be a big box. So let's use a small b for box and a capital W for whale. These are what we're comparing. This box weighs less than a baby whale. So I'm going to just use the symbol less than. And I could also have said that the whale is greater than the box. Because it says less than and not less than or equal to, we don't write the line underneath. The next one says Boston is more than 2,000 miles away. So again, we're going to have B. Let's do a capital B again for Boston is more than 2,000 miles away, where B stands not for the city Boston itself, but the distance from here to Boston. It's more than 2,000 miles away. All right, 2 more to go. That baby weighs no more than 7 pounds. Oh, there's a typo there. That's exciting. Lots of B's. Let's do Y for baby. The baby weighs no more than 7 pounds. This is a tricky one because it does have the words more than in the sentence itself. But it says no more than, so it's actually going to be less than. So it says the baby's weight, we're calling that Y, is less than 7 pounds. We could also say that it is equal to 7 because it's just not any more than 7. While we're here, there's an important concept with inequalities to think about. If we talk about a baby's weight, we can't really say that the baby has a negative weight. If we were talking about just the variable y being less than or equal to 7, that would also include negative numbers. To avoid that confusion, we can write this as a compound inequality, saying 0 is less than the baby's weight, which is true, which that is then less than or equal to 7. This is actually a more accurate way of writing that inequality because it avoids all those negative numbers that are less than 0. All right, last one. Stacy scored no less than a 90 on the test. So we're going to have S for Stacy's score. It was not less than 90. It had to be greater than or equal to 90. And there you have it. We're going to add a few more words here now that we've got the hang of finding those words that tell us there's some kind of inequality happening. All right. We'll do this one together, and then I'll give you some problems to practice on your own. There are 2 different ways to solve a word problem with an inequality. You can solve it with an equation first, and then just figure out what the inequality should be, or from the very beginning you can use an inequality. We will solve it both ways, and you can pick which one you like. Let's read this together. In the city of Louisville, store signs cannot have an area that exceeds 12 square feet. Rick is ordering a triangular sign for his bait and tackle shop that has a base that is 8 feet long. How tall can the sign be? All right, let's focus on some important parts of this word problem. First of all, it says the store signs cannot have an area that exceeds 12 square feet. So we know we're going to be using a formula for area of a triangle. It's a triangular sign. We also know that this is going to involve an inequality because it cannot exceed a certain number. We're going to have to compare the area to 12. And we already know that the base of the triangle is 8 feet long. Our whole goal is to find the different heights that it could be with an area that is less than 12 square feet. Okay, so let's see what we remember. We know we need the formula for a triangle. So the formula for a triangle is area is equal to 1/2 times the base times the height, or the base times height divided by 2. Either way you want to think about it. All right, if we solve this with an equation first, we would take that formula and fill in the things that we already know. We know the area cannot exceed 12. We know the base is 8 feet. And we're trying to find the height. Right now I'm assuming that it's an equal sign. I just want to know what the height would be if it was 12. So, solving this equation, I'd have 12 is equal to 1/2 times 8 is 4, and we have the h left over. And then we'll divide by 4, and we get h is equal to 3. Now remember that this is an inequality problem, so that's not our answer. 3 is not the only possibility. So we want to say that the height compared to 3 is always going to need to be less than 3, because the area needs to always be less than 12 or equal to. If it was equal to 3, then the area would be 12, and it can only just not exceed 12 square feet. So we solved it like an equation and then figured out what the inequality needed to be based off of the words in the problem. We could also have put in the inequality at the very beginning of the problem. For example, we know again that the area, 1/2 base times height, cannot exceed 12. So that would have to be less than or equal to 12. Plugging in the 8, just like before, 1/2 times 8 is 4. H less than or equal to 12. Divide by 4 on both sides. We don't have to change the direction of the inequality because 4 is a positive number. So h is greater than or equal to 3. Oops, less than. Let's fix that. I got too excited talking about those negative numbers. There you go. The height has to always be less than or equal to 3. Now I want you to think back to a couple of slides ago when we were talking about when you can make a compound inequality to express something. This area of this triangular sign should not be negative. This inequality that we've found as our answer implies that h could be a negative number. So we want to add something to it to make it even more correct. So we say instead of h is less than or equal to 3, we say that 0 is less than h because we want to put that lower limit on it, which is less than or equal to 3. So here is our final answer. The height is between 0 and 3 feet long for the triangle. All right, I think you're ready to try some on your own. If you need to, go ahead and pause the video so you can write down some notes. Remember to be careful with those inequality signs. You can add them at the beginning, like we did on the right-hand side of the page, or at the end, like we did on the left-hand side. If your problem means that the answer cannot be negative, you are going to need to add that 0 there on the end. All right, let's try some more. All right, all of these problems are ones that you can solve either way, just like we just did, with an equation first with the equal sign or with an inequality first. As long as your final answer has an inequality, you're doing it right. Go ahead and pause the video and try all 3 of these problems. If you get stuck on one, move on to the next one. Push play when you have tried all 3, and we'll go through them together. Okay, let's try this first one together. A box that weighs 5 pounds can hold up to 25 pounds that each weighs 2.5 pounds. Due to recent back surgery, I can only carry at most 48 pounds. If I want to move the box, how many books can the box have in it? Let's again look for important information. We have 5 pounds, 25 books possible, and 2.5 pounds for each of the books. I can only carry at most, there's my inequality words, 48 pounds. If I want to move the box, how many books can the box have in it? Let's just try some possibilities out. I know that automatically the box is going to weigh 5 pounds. And each of those books is going to weigh 2.5 pounds. I'm going to have to add those together. And let's just say I could fit all 25 books in that box and carry it. If you multiply that out and add 5 to it, you get 67.5 pounds, which is way too heavy. I can only carry at most 48 pounds. So let's use a variable to figure out exactly how many books. 25 is not going to work. But my equation will. I'll say 5 pounds for just the box plus 2.5 for each of those books. Let's use the variable b. And I'm going to use an inequality. You could also solve this with an equal sign and then put the inequality in at the end. But let's do it at the beginning for this problem. At most 48 pounds. So if I'm comparing the weight of the box with the books inside of it, it has to be less than or equal to 48 pounds because it's at most 48 pounds. Let's go ahead and solve this inequality by subtracting 5. I have 2.5b less than or equal to 43. Now to get rid of the 2.5, I will divide. Again, 2.5 is positive, so I don't have to switch the inequality direction. And the number of books is less than or equal to 17.2. I don't know about you, but I've never read a 0.2 book before. Maybe a children's book. But I'm going to say, if they all weigh 2.5, that I'm going to have the number of books is less than or equal to 17. I'm going to round that to the nearest whole book. We could also state our answer as a statement. We could say the box should hold 17 or less books. We cannot hold any more. It will hurt our back. Let's go ahead and try number 2. Number 2 says, in order for David to reach his savings goal, he needs to earn $109,200 in commission this year. He earns 15% commission from all of his sales. If he earned $89,700 in commission last year, by how much does he need to increase his sales this year in order to reach his goal? Let's look for important words again and numbers. In order for David to reach his savings goal, he needs to earn this much money. He earns 15% commission from all of his sales. And this is how much he made last year. So we want to know by how much he needs to increase his sales. So in addition to the amount that he made last year, he's going to need to make some more sales than last year. So we're going to add on 15% of his commission times the number of sales. Let's go ahead and call that X. And we need for that goal to be at least 109,200. Notice that the words at least were not in the word problem. But if you think about the context of the problem, I don't think David would be too upset if he made more than $109,200. I wouldn't be. So we're going to say that it's going to be greater than or equal to his goal of $109,200. Okay, we could also have solved this with an equation and then added our inequality at the end. I like to add it at the beginning so that I don't forget that it's there. Let's go ahead and solve this inequality by first subtracting that 89,700 and moving it to the right-hand side. So we have positive 15x left over, which is greater than or equal to 19,500. And we'll divide by that decimal. Still positive, so we don't need to move the direction of the inequality. So x, or the number of sales, is greater than, that's a squiggle, is greater than or equal to 130,000. He's going to have to make a lot of sales to reach that. Again, we could write this as a statement. He needs to make at least 130,000 sales. There we go. Let's do one more. Okay, let's try the last one. It says Nikki's quiz grades are 73, 75, 89, and 91. Determine what scores, in terms of an inequality, on the next quiz that will allow her to get an average of at least 85. So let's focus on those important words again. We have the word average, we have the words at least, and we have her first four scores. Remember, to find an average, you need to add all of the numbers together and then divide by the amount of numbers there are. However, we have an unknown number in this list of test scores, the very last one. So let's say we add 73, 75, 89, and 91. In order to find the average of all 5 of her test scores, we need to add on the unknown test score. Let's solve this problem like an equation with an equal sign and then add on our inequality at the end. So let's say what we want it to be in order to have an average of 85. To solve, first we're going to multiply by 5 on both sides. This will get rid of that 5 in the denominator. Adding all the numbers on the top, you should get 328 plus x is equal to 85 times 5, which is 425. If you subtract 328, you get x is equal to 97. That means if Nikki gets a score of 97 on the test, then she will have an average of 85. But it could be more than that. Say she got a 98 or a 99.6. Then she would have an average of more than 85, which is what we wanted, something at least 85. So to make this into now an inequality, her score on the test needs to be greater than or equal to 97. We could also make this into a compound inequality if we assume that she cannot on the quiz get more than 100%. Then we could say as well that her score on the test would be at least 97. So flipping that whole thing around, 97 is less than or equal to x, which is less than or equal to 100%. Kind of putting that x in between those two scores. Because we don't know for sure if this quiz didn't have any extra credit, you could say it either way and get a correct answer. There you have it. That's all 3 practice examples. Well done. One great thing about inequalities is it allows us to describe a number even when we don't know exactly what it is. We just need to compare it to something that we do know. Here's an example from the scriptures. In Abraham chapter 3 verse 19 it reads, "And the Lord said unto me, these 2 facts do exist. There are 2 spirits, one being more intelligent than the other. There shall be another more intelligent than they. I am the Lord thy God, I am more intelligent than they all." We don't know exactly how to describe God's intelligence, but we can describe it as being greater than they all. Inequalities allow us to describe things when we don't know the exact answer. I hope you've enjoyed learning more about inequalities and how to see them in everyday problems. Good luck!